Welcome to the next adventure in the Toyotron scooter upgrades, coming to you now in actual quality video. I've abandoned my potato vision camera that I've been using for a while, and we now have focusing, near, far, good quality. So maybe you'll be able to see something that I'm talking about now. The star of the show are these two guys that I explained how I designed and built in the previous video. They are now in place in the prototype board, getting ready for the next step. You can see that they replaced this one in the front, replaced those two, so we're looking at less than half the space and a much cleaner design. So I'm so happy. Now, that leads me to the next little mini project. Part of the redesign of the entire control system involves two relays. This relay, or more appropriately called a contactor because it's a big honkin' relay, this switches off the high current from the battery pack to the motor. So I can run the 60 volts of the battery pack, or maybe 72 volts when I do the upgrade. This will handle 150 amps of power coming through. So that does the main job of disconnecting the battery pack from the motor and the motor controller. The second relay that's going to be in the system now is called the Precharge relay. And its whole job is to protect the JevQ. That's what I blew up when I first energized this a few months ago, and I've been recovering from that ever since. What the Precharge relay does is it runs a very small amount of current from the battery to the motor controller and charges up the capacitors over the course of 3 or 4 seconds to the point where the motor controller is all happy and ready to go. Then when I hit the contactor using the software in the JevQ controller, it turns on and will allow full power to run to the motor controller depending on how I twist the throttle. This is a well-known technique in managing the safe application of power to a newly powered on system in an electric car. Okay, luckily for us, the Precharge relay doesn't need to be this big. You've seen the concept of what are called automotive relays. If you've got your own car and you ever lift up the hood, there's a little plastic box full of very small relays, about 1 inch on a side. And they could do the job for us because we're talking very low current at this point. But instead of 12 volts that your car is working with, I need a 60 volt relay. And those are not easy to find. So I went off to China and I bought this relay. It's about the same size as a standard automotive relay, but it handles higher current and higher voltage. It'll do 10 amps at 250 volts AC, which is just huge, or 10 amps at 30 volts DC. I'm having to cheat a little bit on the 30 volts rating. Basically what this is saying is it can handle 300 watts continuous duty. But I'm only going to be running maybe half an amp at 60 volts through it, which is only 30 watts. So that's 1/10 of what this relay is designed and rated for. So this guy's going to be fine for us. Now, in my prototype system, it's going to go right here. But that's not going to work because everything else has big honkin' wires and connectors off it. And this guy, unfortunately, is designed with pins to go into a printed circuit board. So I'm going to need to design another little widget that takes from this to something that I can bolt wires in and out of. So I've got a small prototyping board, which is just a circuit board drilled full of holes. I'll mount this guy in here, and I'll mount these little PC board mounting connectors. The holes are a little tight. I don't want to jam them in until I'm really ready to go. And there'll be 2 to control the on and off of the relay, and then 2 to handle the power that will flow through. So the layout's going to be something like this, and that's good. I'll cut the circuit board down to size, and then of course I'll build a little 3D printed enclosure around it, which will allow me to have access to the sides, but it'll be sealed with a cover with maybe little screw holes and mounting points the same way that I've designed this. So that's what we're shooting for. So let me jump on this and see how we do. And we're back. After a little bit of measuring and drilling and tapping these guys in and the relay in and doing some soldering on the back, we now have a functioning relay board. You can see there's connector for the minus side of the coil, connector for the plus side of the coil, connector for this side of the on-off contact, and one for that side. And I've cleverly marked plus and minus because I've looked at the drawing for this relay on the web about 30 times to make sure I got my polarity right. They actually give the view on the spec sheet, the underneath view. So you have to flip it over in your mind and realize that this is the plus and this is the minus. So we're in good shape, and you can see I doubled up the connector here and here, doubled up the connector here, and then ran this guy way around to the other pin and used a couple of spare points to tack it down so nothing will move on this side. It's strange that their relay contacts are like this instead of like that, but we now have a thing. Now what we need to do is build an enclosure for it, because I can't have this just sitting in the bike, even though it's going, all of the delicate electronics are going inside a project box of some kind. So let's look at what I did for this guy. So this is attempt number 1. I just wanted to build a flat box and with some locating pins for those mounting holes to make sure I had the orientation and the spacing right. And I'm leaving a gap for where the wires come in and building a wall around the outside. And of course the mounting pin locations was not correct. So we go to number 2, and I made it even worse for the mounting pins. So I went to number 3, and it fits. I feel like the king in the castle in the Holy Grail. I built 3 castles, they all fell down into the swamp, but this one fits. So I'm on my way. So what I want to do now is extend the walls, turn these locating points into screw hole mounting posts. So we move to number 4. We've got a gap in the side. We have mounting posts with screw holes in them. This goes like this, and you can put your wires in from the side. So first, it's a little short. I need to make that higher. The holes, even though I measured, the holes are far too small for the screws I plan to use. So I need to widen this hole inside, and I want to make these posts higher because I'm working with a screw that's this big. And even if I use a washer like this, so it goes screw, washer, and in the hole, I need to have this much body of the post to go down to secure this into the hole. So, and I also want to make a lid that goes on top, and I want to be able to snap it into place. I don't want to have to worry about extra screws. So I found a really, really good video on YouTube about how to design the bottom part and the lid for a snap-in, and that's what I did here. Unfortunately, while the guy was really, really good at Fusion 360, some of the things he was doing did not seem to apply to my model for what I had. He was selecting things for me that wouldn't select. He was extruding. He was doing this and that. And I tried to follow along, but it didn't work out very well for me. But I managed to make something of my own that will try and work. So let's have a look at this. You can see there's a little triangularly shaped ridge at the top on both sides. And then on the lid, there is a bar on each side with a little triangular cutout in the side right there. So this is meant to snap into place. So if we put our guy in here, the sides are high enough, that's good. Of course, the mounting hole is still a little bit too small and too short, so the next rev we're going to fix that. And the mounting clip, it clips. Come on. It does clip, but it's not really a locking clip. I shaved the parts back a little bit to give me some clearance that I thought I was going to need to get the piece into place, but it just doesn't have enough teeth and bite. So we move to the next one. So again, we're in place here. That's all good. I expanded the size of the triangle here, and I slid this bar over and deepened the groove here, and we have a very pleasing sounding snapping feeling. This is good. I like that. It's going to be inside the project box, inside the bike, and I just need a way to keep this lid on. So that is really, I'm very happy with that. Need the post higher, the holes a little bit bigger, rounding some things off, adding some bracing around the posts. Oh, and I also forgot, I wanted to be able to label the connection points. Wanted to put a label here and a label here. And despite the success I had with the bus bars doing black and red in the same print, I could not get Fusion 360 to give me a way to print a red label. I was trying to make some slices and it just didn't work. So I ended up making this super 0.5 millimeter thick plate with the printing on it, Precharge relay, contact this side, coil plus and minus, and I'll just glue that on. I'm not worried about that. But of course, I got the orientation completely wrong, and since this box is 3 millimeters unsquare, that's not going to work. So we come to revision 7. My posts are higher. They now have a filleting reinforcement on the bottom. I filleted most of the edges. This guy goes in here. This guy snaps into place very nicely, and the orientation of the printing on this is good now. I can just glue this tiny plate on top, and I used a red paint pen just to run it over the top of the letters, and that's fine with me. I don't need the 3D printer to make red letters for me. I'm okay with this. It's going to take 30 seconds. So all in all, there's our contact points here, labels, secure, everything's reinforced. So I'm happy with this. After 7 revisions, I'm going to do a big print, probably in medium, because there's still a lot of flex in this. The flex in this doesn't matter, but I want this to be quite strong. The bottom is quite thin, so I'm going to print this again, final version, final. Mount this into place, and then we're pretty much ready to start retesting and rewiring up the prototype and see what happens electrically. I have no other mechanical fiddling that I need to do. Okay, just to wrap things up, we now have the final base printed. The snap lid and the label is glued on the top with some glue or some paint that's drying, so I'm not going to mess with that. But what I've done is I've wired up the 12-volt power supply coming in over here into the coil, and you can see the orientation, coil plus, coil minus. And then what I've done on the output is I put a battery in series with that horrible beeping speaker from the original motorbike that went meep meep when I had the blinker on, and I immediately tore that out. So as I switch on the power supply, the relay will energize, current will flow, the speaker will go off. When I switch it off, the relay should instantly disengage. But if you'll just see over here in the corner, the power supply has a little LED that, and it slowly loses power because of the output capacitors. So the relay will not disengage immediately in this test setup. It will once we've got the full simulator built. So power on here, and we'll switch on. And power supply runs out of power. So we're energizing the coil, complete the circuit, beepy beepy. So everything's good right now. Snappy snappy. And it's chooching. Skookum chooching. One more time for posterity. Okay, now on to the real simulator. As a supplement to the project, I'm now back at this. This is version number 8, and the relay's gone because what I realized is I was missing a significant part of the project that I could put inside this box. You ever work on something and you get so far down in the details that you forget to look at the big picture? Well, that's what I did with this. So I went from this to a prototype of the new size that I need, and you can see the difference. Basically brute forced Fusion 360 to make this box bigger, and the lid and the lettering, and change the lettering around. That was number 9 to the final version, number 10. So what I've added is this power resistor. It's a big ceramic resistor designed to take a lot of heat. This can do 10 watts, and a normal resistor that you would find on a normal circuit board, which is about this size here. This is a 1/4 watt resistor compared to this guy. So this will take 40 times the power flowing through it than this little guy does. This Precharge resistor is the thing that when we first power up, it allows a small amount of power to flow into the motor controller. Not a lot, not too little, just enough over the course of a few seconds to get those capacitors charged so that when the JevQ turns on the main contactor, everything is good. So this thing has to be in the system somewhere, and instead of hanging by its wires and vibrating around and attached to something else, I thought, all right, I'm going to put it right in here because it needs to be in series from one of the legs of the contact of the relay. So you can see I've reprinted the top lid, and the coil is the same as before, but the contactor on this side, this terminal goes to the plus battery wire coming into the contactor, and this terminal goes to the plus of the wire going to the controller. So it's it'll all be explained when I show off the full schematic later, but I now have a fully prepared Precharge relay solution. So I wasn't going to take you through the pain of getting from this guy to this. I just wanted to show you where I ended up. So that's the dumbass alert for Mikey for today.